Now, something like this, I've played around and got this thing all different diameters. You may want to take a bunch of cuts across if you really want to use this for something, and just try to go ahead and clean it up. You'd be careful touching something like this, you can cut yourself. Now the feed rate on this thing here, you may wonder about. If I change the gearing on the back, it's going to go through and advance this faster or not so fast. So if I set this up for a coarser thread on here in the gearbox, it's going to go through and advance the carriage quicker this way. So besides, you know, gearing, changing the gears in the gearbox and the side of the thing determines how fast this is going to move for a given RPM. If you set this to a certain RPM over here, how fast this carriage is moving, you may say that's going bloody slow, and it might be going too slow for whatever you're trying to do. Now the way the chips come out are going to depend on the cutting speed, the material you're cutting, how deep a cut you cut on there, and sometimes it gets in a groove and it'll actually cut. Certain materials will come off just one big wire. I was cutting some stainless 301 series the other day, and it came out in pieces about 2-3 feet long. It just would come out like a big spring. Now, when it's going through here and cutting some past spots that are different diameters, it's going to want to not be so clean, because what it's doing is changing the force on this carriage. It's actually cutting and not cutting. And so it's, from a macro level, it's bending this back and forth, because nothing is rigid, even on any lathe, even on a $zillion lathe, it's not totally rigid. So you got to be aware of how deep you're taking cuts and things. Now over here you see it's not even cutting at all, because I've gone through and buzzed off the high spots. I can go through here and start to make a cut. Again, normally when you want to cut something on a lathe, you don't want to have the piece of material stick out more than a couple diameters, 2 or 3. You can stick it out farther than that. It's just that you're going to have a more of a floppy thing out there to cut. You risk it popping out of there during the cut. Also, you're not going to get an accurate piece. So on a long piece, I always run a center like this. This is spinning around on here. Now in this lathe, it's interesting. Let me turn this all the way out. I'm not sure if there's a protection on this. Let's say it is spinning. Yeah, I'm actually hitting the workpiece on there. I was going to see if there was actually a safety. I don't think there is. Now when you got this spinning around here and you put your hand, you can get some chips that are like totally going to bite you in the hands. That's kind of dangerous to do what I just did there. On the stainless material I was cutting, you can get some splinters on there, cut right through your hand. This is a 3.5 4-jaw truck on here. There's a self-centering one. There's a 4-jaw. This is 3-jaw chuck. There's a 4-jaw chuck you can get on this. And you go in here and undo the chuck plate with these bolts back here. Take the chuck off. That doesn't come with this. Those are probably $100 if I had to guess. Anyways, it's nice, not a bad little lathe to play around with. It's like anything else. As soon as you get one, you want to get a bigger one. This is a Morris taper too. If you get a giant ass lathe that's way better, you can get one that's got collets that'll fit into this piece. This is the gizmo, so you don't turn it on. Don't sue me. You pull that out the back like that. You can see I was getting down close to the diameter, the inside diameter there. Now you can take this piece out here on this lathe. You can undo this and you go turn it this way. It'll pop out. Now there's also a chuck that will go in here. So you can go ahead and replace this with a chuck, and that's in case you want to go through and let's say I want to go through and tap a hole in here, or I want to bore a hole. You can go through and what have I done here? Let's say I wanted to bore a hole through this thing. You can go ahead and put this in place. You replace this guy with a chuck that they sell, Morris taper 2, and then you can go in here and you can bore a hole through this thing if you want to open this up to tap a hole. So that's what the tailstock's for. Tailstock's to support long work with a center like this. You can also use it to bore holes in there, a lot of other things. Now if I wanted to, I could take this piece off and have a giant piece unsupported here and do the full 10-inch. This says 7 by 10, but of course having something that big unsupported, you'd have to take real light cuts because you're kind of violating a whole bunch of different rules. There's also a max size you can run through this, which is probably closer to 1 inch. Now you can take, there's 2 sets of jaws on this. There's inside and outside. You can flop around. There's also 2 different sets of RPMs on here, 1100 and 2500, and that's going through back here and changing the gear on it. There's also a reverse on here where you can make the thing go into reverse.